Good morning, everyone. Welcome to this talk. It is called Spring into Action, a Reactive Story. I'm Chris Garia. I'm going to be giving this talk to all of you. So, first things first, what is this about? This talk came from a conference called Devoxx, which is a Java conference. I'm going to be going over some current industry trends and talking about cutting-edge technologies and where we're headed. So first things first, what do I mean by a reactive story? Is this a fairy tale? No. What this is a journey towards understanding why reactive is important and how we got to reactive and why we actually need reactive and what it means to us in our particular industry and our particular jobs. And also spring into action. Are we going to get off our chairs? Sorry, no. We are going to get our hands dirty. We're going to try things out. We're going to look at what Spring 5 has to offer. And we're going to try to apply it to everything we've learned. We're going to look at Java 9 and Spring 5's reactive programming implementation. So, in summary, what are we going to do? We're going to do some stretching. First things first, we're going to brush up on basics of clean coding. I know this is not strictly reactive, but I think it is quite important to get to grips on some of these basics. I believe there are already some talks at the moment about clean coding and things like that, so I think it will fit. It will also give us some chance to remember our coding skills before we start. And then we're going to get motivated. Like I said, this is going to be a journey. So first we're going to tackle the pitfalls of concurrency in Java, brush up on what reactive programming actually is in the first place. I'm sure most of you actually know most of these things already, but bear with me, we're just going to go over it just for a bit of a holistic picture. And finally, we're going to tackle the direction of Java and rapid agile development. These things have a direct impact on the direction Java is taking, and developing software at speed, in inverted commas, has certain implications in itself. Finally, like I said, we're going to get stuck in. We have Java 9's new features to go through and Spring 5's reactive programming implementation. We're going to try our own little project and see how we go with that. Hopefully we'll get to it within the right time frame. I think we're doing okay. So just a few things. Vox Conference was in Poland, specifically for Java developers in particular. Has details about current technologies, cutting-edge stuff, and all these things. Talks given by people from IBM and Pivotal. The Pivotal people specifically gave some details about the release of Spring 5 and how Reactive is going to be used with that, and hopefully we'll see it all together as well. Most of what you're going to see came directly from talks in Devoxx, including the clean coding and things like that, and also some opinions and suggestions are also embedded in the talks and sections that we've just gone through. So, let's get started. Clean code. Why bother? So essentially, clean code is an extremely important part of our daily life. Why? Because we spend just about 80% of our time reading and maintaining existing code. This means that we need to know the code properly, we need to be able to understand the code properly. Otherwise, it's a lot of time wasted. Clean code makes code more readable, easier to understand and easier to maintain. It can also offer some speedups. Clean code has the ability to make sure that we slice up methods properly and that the compiler can then optimize code accordingly. Like that, we can actually gain some small speedups here and there, but win-win on either side. We're also going to cover some basic principles. A bunch of you probably know all these. It's don't repeat yourself, keep it short and simple, take responsibility principle, and inversion principle, the dependency inversion principle. Okay, so on that, we shall get started. But first, how does one measure good code? Good code is extremely important. Like we just saw, there are a bunch of things tied to good code. Understanding it, maintainability, and getting exhausted at reading code is also a possibility. How do we ensure that we have good code? Do we use things like Sonar only? Is it just the technical features? Is it just how many comments per line and comment density, or is it just the size of the class or the cyclomatic complexity? Remember that when we are coding for people, not for machines. People will curse. If they don't understand your code, you will quickly find out. There is a measure called WTFs per minute.
WTFs per minute?
Yes. Which I think is a fairly good indicator of whether you've coded properly or not. Remember the principle of least astonishment. Code should not surprise us. You should not be baffled by what you're looking at. You should not be frightened by what you're looking at. You should know exactly what's going on. We should remove the fear factor of refactoring code. This, I think, is something quite close to home to many people, where you just build something complex, it's taken you 2-3 days, a week sometimes, you got to the bottom of it, you finished your stuff, you've got a method of spaghetti code everywhere, you run it, tests pass, feature is working, it's done, don't ever touch it again. That has a fear of refactoring it. That is the biggest problem with clean code. You have to refactor. You have to remove the fear of refactoring. If there is a fear of refactoring, it's a good chance that the code is not good. So let's start with some aspects of clean coding. So naming. Like I said, code for people, not machines. Machines can understand spaghetti code fairly well. Okay, maybe we do some aspects of optimization, fine, but it will work perfectly fine. We are not machines. We need to understand the code. Use meaningful naming conventions. So basic stuff. So functions as verbs, classes as nouns, booleans return a yes or no answer. So for example, as a function, search product, and as a class we should use client and product itself. And booleans return yes or no. This is something which is quite common, I think, even in PNCP. Instead of is alive or are valid, we get alive and get valid. Bad naming convention. Next thing is avoid meaningless naming. Order info, order data. Can we tell on the surface what the difference between those are? That's not clear to especially new people who are approaching the code for the first time. New modules, especially we who are microservices, tend to have our own little team's conventions. Do we know what the difference between order info and order data is? How can we tell? Should be pronounceable. Unknown method is not easy to read. If it's not easy to read, someone might not understand it. What does PRNCT mean? Don't know. It should be unique. Account versus organization. This is something which is in PNCP and has been dragging along for a very long time. We've also had multiple spellings of organization within different modules. And avoid inventing abbreviations. Get from cloud is not clear. That get model from cloud, get model from cloud, get supermodel from cloud. What's that going to give us? Obviously, that's not referring to using well-known abbreviations like VAT or things like that. Something also worth noting, which isn't part of these. Actually, first, before I go to that, be confused. And fetch or find by name. Do not get confused between the two. It should not be both at the same time. Okay. Also worth noting is that don't repeat yourself. So don't ensure that while you're doing all these, you don't end up saying sort of get order info details and get an order info name, get order info this, get order info that. That is constant repeating. There is no need. If you know what class you're in, what you're doing, and what data you're retrieving, there's no need to keep repeating yourself over and over. And that we've also tackled a bit of understanding of the dry principle. Interfaces. Interfaces are not always necessary. Remove them where not. We have a tendency that services constantly implement interfaces, ending up with a convention of impl constantly in every different direction. It's not always necessary. Remove where not. Leave interfaces for these kind of occasions. So remote endpoints or specific design patterns like the strategy pattern, which loads classes at runtime, and version of control, similarly. Interfaces and for services in these kind of situations is very, very handy, yes. And we can work well with that. So, functions. Functions should be focused. Should have a single responsibility and follow this principle. Methods should not be long. You should understand exactly what you're writing and how to describe it. The naming of the function is also as important. Describe the function properly. The function should be, in general, rule of thumb. Don't jump at me, and this is part of a book which I can send you. 5 lines to an IDE page long. There have been methods in PNCP that came to 500 lines long. Slice it, it's fine. Avoid nulls, both as a parameter and as a return type. As a parameter, if we're expecting null or null is going to happen, only require validation at the boundaries. When returning a null, if we have to return a null, wrap it at least in an optional, so someone will know exactly whether they can return a null or not, and not find some weird null as a response. Throwing unchecked exceptions is fine. There has been some pushback in certain aspects of this. It is somewhat arbitrary. Like I said, this is some parts of this can be quite up for discussion. But there are benefits to throwing unchecked exceptions. Unchecked exceptions can be left to bubble up and handled by a global exception handler, which means that then also error messages can be handled centrally, and also internationalization can be done from one central place. Like I mentioned before, fear of refactor. Refactor often. If the method is going to grow, slice it. It's fine. A method will be touched by multiple people for multiple things. The logic might change. Just refactor. Slice it up. Keep it small. Keep it concise. Keep it focused. Classes. We have a tendency to completely forget how to use OOP correctly. Object-oriented is not strictly procedural. We tend to imitate business processes. Business processes tend to be very procedural in nature. It doesn't have to be projected that way in OOP. All we have to do is understand exactly what we're doing, and then everything will be fine. It should practice data hiding. This also might be subject to discussion. Data hiding refers to not exposing the sheer constructs of your POJOs and objects. Expose logic rather than the internal construct. So, for example, if we have a car and we have the fuel in liters remaining, do not say get fuel remaining, get range remaining. If you're going to change the internal workings from liters to gallons, no one gets affected. The range doesn't change. This kind of calculation can and should, some may say, be done within these objects. As always, keep it short and simple. Classes shouldn't be so super long. They should range between 200 and 300 lines of code, rule of thumb, of course. When classes get long, slice them up. If slicing them up keeps them long, put different aspects of the class within different service classes. Different service classes, classes come free, it's fine. Create new service classes and we can keep code focused. Comments. This is enforced many times by Sonar, but if we adhere to what we're saying, comments shouldn't be strictly necessary. They shouldn't be the only way that we understand the code we're looking at. Our naming should be good. Our functions should be concise. The naming of the functions and our variables should be perfect. Together, these things should read like prose, almost. That being said, there is place for comments. Let's start with the bad ones. So, and these are, some of them are examples which we've seen sometimes in PNCP as well. So first one is mumbling. I need a holiday. Give me a break. Let me go home. I don't feel like. Pass this on to the next guy. These are mumbling. This is useless comments. Redundant. Public get date. Comments return the date. Thank you. No shit. Position markers. Delineating this piece gets getters. This piece gets setters. We have had occasions where there are so many in the class that we don't understand what's going on, and there are these delineations. Should they be necessary? Commented out code. This is something perhaps some people have left behind in certain things they do. Maybe they forget what they're doing and leave it there after they've tested something out. And over-involvement. People tend to give a bit too much info constantly leaving comments. This line I'm going to do this. This line I went to the toilet. This line, and all this over-involvement in the code commenting. That being said, there are some good comments that we can add. So for example, when code can't describe what's happening, for example, an algorithm, In this case, so if we implement the bubble sort, you can say implementation of bubble sort and leave a link for someone to understand how to implement that and what's being implemented. Clarification. This method will do a somersault, then a card trick while you're looking away to steal your wallet. These are little simple things that the method cannot describe properly. That these might be difficult to understand as people are going through the code, and it's just good to have a bit of a summary over there. Warnings, not thread safe. This can be very, very important, especially in concurrency. To-dos, this might be helpful for development, and Java docs and legal manifests. Of course, we've all added these kind of annotations before. So, finally, part of this clean code is clean lambdas. Lambda expressions are becoming very, very popular even in PNCP, and then anyone who's implementing Java 8 in their code. Clean lambdas are extremely important. Slice up expressions and predicates into their own methods. Clean lambda expressions can become very noisy and very dirty very, very quickly. We were going to go through a little experiment together, rather exercise rather than experiment. And this is a lambda expression from product services in PNCP. This is currently in production, and this was made by yours truly, and I'm so sorry. This is approximately 100 lines long, including the business logic within it. This is not by any means the only one of its type. There are different people implementing different things, and this is easy to achieve just by appending constantly to the lambda expression, constantly adding another condition, constantly adding another piece. Can we make this any smaller? I think it can. So I'm going to try to go through this slowly. So basically what we have here is an iteration of a parallel stream given a collection. We'll have a filter on that collection given number of conditions. Okay. So once we've filtered out those, we're going to reiterate the result of those. Okay. Then we're going to refilter out some bits and pieces from the results. Have more conditions over there, and then do a chunk of business logic. Okay, fine. So this is a bit of a hassle. So first things first, this section. So super easy. It's even closed in within brackets. Let's remove that. So clean the mess. Extract the business logic from there entirely. So create its own method, add parameters, and add the business logic over here. Super simple, super easy. Next thing, remove the predicates. Put the predicates in their own method. Slice them up. Like we said before, refactor. It's fine. We return the result of this expression, and this expression now has a name. There's an expressive name. People can understand and read this. Split those two sections up, both for the parent, one for the child. Our final result. 5 lines of code instead of 100. Much easier to understand, much easier to read. Our method's now more concise, more maintainable. Let that sink in. Any questions? No, the second filter is on part of the first, or on the result of the first value. So.
But on the first sense of the scale, when it was intended, I think this below for each, which was actually showed quite a difference. So
no, this is just indentation. Sorry, this is just indentation.
I don't know how it was, but
no, this is just indentation from. Sorry. No, this filter piece is after this parallel stream from the values in this for each itself. So this for each is closed here. Okay? So the filter is within there. It's not redundant. This is better like this. There's an indentation here to show this within for each. Make sense? Awesome. Anyone else? No? Cool. Awesome. So moving on, let's get motivated. Java concurrency. Now, Java concurrency can be a bit of a headache sometimes. It means that the developer is going to have to manage everything themselves and understand concurrency and the problems that concurrency brings very, very, very well. In Java, even by spec, it can be counterintuitive and at times seem broken. This is something even written within the Java spec document. There is a lot of behavior within Java which is legal, which causes us, if we don't exactly understand what's going on, to have very counterintuitive results. The spec is available here for whoever gets their hand on these slides. Go through it. This talk is based on chapter 17.4, which is Java memory model, if anyone's interested. So let's move on to a bit of an example. Basic concurrency issues. race conditions. So we have thread 1, thread 2, shared variable A, then shared variable B, a variable X, and a variable Y. Intuitively, if we didn't understand how concurrency works, we'd say statement 1 executes, statement 3 executes, then statement 2 executes, then statement 4 executes, at least in line. This, of course, is not the case. This should result in this case if we don't know what variable X is and variable Y is, because at the time of their assignment, there is no value assigned. This, however, is not true. Java can decide to run these in any order it feels like. So it decides to run thread 1 first, go through the statement 1, statement 2, statement 3, statement 4, with a different result here. Okay, so now variable Y is set because the shared variable B is set. Okay. Similarly, it can go the same through thread 2. So we have statement 3, statement 4, statement 1, and statement 2. Now we have variable X set. Okay, this is different again. It can even decide to reorder within the same thread altogether. That can happen, especially since the dependency is to the right, which means that the assignment of X is not dependent on shared B, and the assignment of Y is not dependent on shared A. So these can even be changed in order, which means shared B can run, shared A can run, and X and Y both now have a value. Completely inverted everything here. This is legal behavior. These represent race conditions. Java does not provide any guarantee of order, especially, actually only, since variable, it doesn't matter. It can be reordered. It is legal.
An optimization, which is only done if the second line
is not dependent, and it is entirely isolated. Yes, it is entirely isolated. It can decide to change the order in which it executes. Yes, yes. Okay, and you will see this is something called program ordering, and we will tackle it in a second. And because not only can it change orders, it can also change threads. We'll see.
And in this case, right, post line 2 and 4, you just an assignment. So there's no dependency.
There's no explicit dependency on what came before it. Again, this is completely isolated within its own thread of execution. There it can reorder, because this is shared A is not dependent on anything in Y or anything that can. Mm-hmm. If shared B was equal to 1 and shared A, yes. Yes. Then it will share the order, yes. Okay? Atomicity. We have an assumption that a lot of Java's primitives are atomic. Actually, first of all, atomicity is the ability to execute something on its own. I'm not explaining this properly, but at once, perhaps, in one statement or in one set of statements which are not interrupted. Makes sense. Not all primitives are atomic. Double and long are not atomic. Doing tasks on them in concurrency can mean that if we set long A in thread 1 to be one value, thread 2 tries to access that value without being synchronized. Thread 1 will store high bits. The thread 2 will access the high and the low bit in between, and thread 1 will store the low bit later. Thread 2 now has a completely different value. This is possible.
Do you know if this is only an included systems or?
In both thread 2 and 64. Yes, 64-bit systems also have treats the underlying thread 2. So yes, the stores are twice.
There's the atomic.
Then they have specifically atomic classes, yes. And we'll also go through the synchronization modifiers at the end. Okay? But this, remember, we are talking about scenarios where we are not synchronizing any variables. This is strictly shared variables and multiple threads. We're just highlighting the problems of concurrency here. So this is what I was telling you before it. So the way we execute this kind of statement. So we're talking about data and control dependence. So in a simple statement like we see on the left, in a simple code block like we're seeing on the left, we have shared X, shared y, a condition on shared x, and a statement. This will be run starting from the end. We will have one branch which will start from the condition of printing, the control condition, I guess. From printing, printing has a control dependency on the condition. The condition has a data dependency on shared x. This is one entire branch. Shared y features none of them, has no dependency, is set on its own. We now have two branches. These two branches, the JVM can decide to run in parallel, without us forking, without us having a future. Without us using a future, rather. We also have a fantastic future. These can be set to run in parallel. And this is not decided by the JVM implementations, it's decided by the hardware. We are forced to use our hardware as best we can. Therefore, this kind of optimization is necessary. And this is how we can decide to reorder certain things for us. Does that help at all, Alan? Makes sense? Yeah. Okay. So finally, let's say we're getting synchronized. We have modifiers in Java to say final, volatile, and synchronized. Final sets on a variable. We'll make sure that it is initialized before the constructor, if I'm not mistaken. Volatile ensures that the reads and writes to the variable are atomic, so it solves the problem that we had before. And synchronized ensures that the code block in itself runs atomically, but even in the order inside it can be changed, like we just saw before as well. But at least that piece runs atomically. Okay, makes sense? Any questions? Awesome stuff. So, more motivation. What is reactive programming? There's a bit of a mess online on what reactive programming really is and how it actually makes a difference and how it works and things like that. Let's just tackle the basics of this. So first things first, it's a different programming paradigm. It's a different way of thinking and it's a different way of doing things. Reactive programming is a mentality and a methodology before anything else, before any implementation, and it is an understanding and a philosophy. It should offer immutability and statelessness, two things which are highly desirable to forego about a lot of concurrency issues in Java. A lot of the concurrency issues we saw before come because of a shared state. It should adhere to a number of manifestos, a number of criteria according to the manifesto. That is responsiveness. A reactive program should exhibit responsiveness, which means that it should reply in a timely manner to data or to requests. It should be resilient, able to cater for errors and exceptions. It should be elastic. It should be able to change according to load. And ultimately, it is message-driven. It is completely a way of implementing an asynchronous, message-driven philosophy or methodology based on the observer pattern, where that handles back pressure. Now, something extremely important when understanding reactive is back pressure. So back pressure is shown by these bunch of marbles over here, or beads, whatever tickles your fancy. Back pressure refers to a concurrent situation where multiple sources are producing data at different rates. In the architectures we work in right now, especially in microservices, and even the way we work in PNCP, we are touching a lot of different bits and pieces of different components, which all may function at different speeds. It is extremely important for a reactive program to be able to handle this. It is called back pressure. Okay. And ultimately, reactive programming implements a producer and consumer method, or an observer pattern. Ultimately, what we want to do is take outputs from producers, reactively combine them, and give them to a consumer. Now, the diagram over there might be misinterpreted or moved around and things like that, but ultimately what we mean is that we have multiple streams of data. We have to combine them into a way where we can protect our consumer and be able to safely handle back pressure. Make sense?
So the result can be, like, give me a result every 1 second for every 2 seconds. So
it can, yes.
Be by time or by any other.
Exactly. Exactly. Reactive combination of these streams can be done in any manner and in any large amount of ways. You can take a look at an example online called RX Marbles if you have the chance. It will give, I think Xavier has found it. It will give a very, very, very good graphical overview of how reactive streams are being combined for a consumer.
This includes the concept of back pressure as well.
Entirely, yes. Reactive combination definitely has to include back pressure. So ultimately, you are reactive if you handle back pressure. Asynchronous streams without blocking, without an I/O blocking back pressure. Okay, make sense? Okay, docs. Any other questions? Maybe in Serbia? Yes. Depends entirely on the way you reactively combine them. Some of them will zip them together, some of them will just interleave them, some of them will decide an order for you, from one over the other. It is entirely dependent on the reactive combination, that is. There can be any number implemented differently and things like that. Again, if you ever needed to try RX Marbles, extremely good to understand this. Yes, awesome. Cool, yeah, that gives us a little bit of an understanding of reactive. So reactive here, we've said, is tackling our concurrency and there's difficulties for us. So ultimately, once we know all this, agile development. We are developing large applications as fast as physically possible. And ultimately, we want to be first to market. In that sense, it is extremely important to us to make use of such tools. And reactive is one of the major things, major participants and major factors in this. Java is making a shift to functional. Functional is part of the world of declarative. We are moving from an imperative way of thinking, of determining what to do at every single line, how to do at every single line, and to a declarative state in where we want to say what we want to do and that's it. We are now implementing lambdas, we're implementing different notation entirely to our statements that we were looking at before. We are now tackling loops and conditions and filters through declarative notation. This helps alleviate some of the tediousness that can be brought on by constantly coding statement by statement different aspects, and helping us develop things even faster. Java is becoming reactive. It is implementing the flow class and producing interfaces called publisher and subscriber. These are building blocks for frameworks, especially. As far as I remember, it was mentioned it was not really meant for people to touch themselves. It was meant more for framework building and people who are actually going to implement a reactive system. But finally, ultimately, when an agile environment, we should consider the test-driven development. So we start from a test and build our feature towards that. Don't start with coding, start with testing, and build slowly towards our feature. And finally, the correct use of QA. We tend perhaps to misuse them in this sense. QA are people who we could use to get a person's response, rather than getting a machine-like response. It is not a matter of testing whether a click works. It should be a matter of whether the click makes sense. It should be a matter of understanding whether positioning has changed, or whether the user experience has changed, or whether user experience even makes sense. There's user acceptance testing and things like that, which should permeate as part of our methodology of developing. Okay, so let's get stuck in. But before this, we've moved through a bunch of topics already in this first half hour or so. Does anyone have any questions? No? Makes sense? Okay. So, this is the part where it can go horribly wrong for me and make you laugh very, very much. So, let's get stuck in. Let's start with Java 9. Java 9 is slated for a release either sometime end of this month, 27th July, if I'm not mistaken, or I'm not sure whether it has moved to September. Sometime this summer. September, as far as I know, is moved again. Yes. And in fact, this was one of the warnings as well by Spring, that they're going for Spring 5 based on Java 9, and Java 9 is moving left, right, and center. But that being said, it's coming out. There is a pre-release version available for people to tinker with and to toy with. Also, that being said, Java 9 is coming with a host of new features. Let's get excited. JShell is a bit of a toy. Bear with me while... It's a bit of a toy. Essentially what it's going to do is give us a bit of a platform to test Java code without needing to start a Java class or fire up an IDE and compile the code and then run the jar and all this fast. Essentially, it is just a command line tool. So let me just flip over the screen here.
Sorry, Christian, do you share other screen? As we
Yes,
don't
yes.
see anything.
Coming ahead.
We are still on the presentation.
Okay. There we go. Okie dokes. So bear with me. Here we go.
Better now, thanks.
So log into a VM over here with Java 9 installed. So let's fire up. This is got Java 9 there. Let's fire up JShell. Yes. Okay. Yes, can anyone see? Awesome. JShell, welcome to JShell. Okay. String name equals Chris. Name is Chris. Awesome. Output println name. Like I said, bit of a toy. I believe so, yes. There should be... haven't tried it.
So what was the question?
Clear the system.
Okay.
There is a drop, yes, but I haven't tried it yet, if I'm honest. Sorry, I haven't tried it.
I'm sure that, yeah.
There is something I'm sure, 100% sure, yes. I mean, if anything, just exit and start playing. We've dropped the entire thing and cleared everything else like this. So, okay. So, that is going to give us a bit of a platform to try some stuff out. If I can get this out of the way. Nope. Exactly that. So, Java 9 then no longer allows an underscore as a variable name. I don't know if this affects anyone or if it makes anyone sad, but if you do something like string underscore equals hello, sad. As of release 9, underscore is a keyword and may not be used. This is in preparation of Java 10, apparently.
Underscore alone or?
Underscore alone. If we decide to be completely creative and do double underscore, oh lord, it works. Bit of an iffy thing there, but okay. This is apparently in preparation of Java 10. Okie dokes. Next. If this would go away. Stream API improvements and optional streams. Optionals may now be streamed. I have a number of optionals over here. I'm going to try one out, just one of them for the simple sake of. We have drop while, take while, and of nullable. Let's do drop while just as an example. So what drop while is going to do is, let's say I'm going to take an int string dot range 0, 0, 10 actually. Dot drop while will give us the ability to have a condition on that string without filtering, which the filter will flip halfway through. So basically, condition I is less than 5 will give us another string, and for each we will system.out.println. Let's do it. Function. So this is going to give us a specific condition, and it will release a stream with it. So with the filter, we would have to do something like range that, filter greater than 5, less than 5, and actually, I'm not 100% sure what's the difference between them.
Exactly. So
it will just give us a condition right off the bat like that. We'll just drop whatever there is, so we don't have to stay saying like.
Just my hunch is mostly for reactive.
Yes.
It can be received in a different.
Possibly if you're doing it with Flux.
Time and not just as a bunch, all of it.
Possibly use Flux, yeah.
Some support for actual
yes,
reactive.
that would make sense.
That would just you will have it already there.
Dealing with back pressure. No, we should all know back pressure. Dealing with back pressure. This would be exactly. But this is a silly example to understand exactly what's happening in drop while. Next, interfaces with private methods.
Sorry, what were the other functions?
That's take while and of nullable. I haven't quite tried them before, but a similar method. So take while presumably takes prefix and things like that. And optionals can now be cast as strings, which means that we can do optional of I don't know if this works. Dot string. Yep. So I have a stream of options like this, which can be handy in some situations, especially if we're using it within a Lambda expression and within a set of strings, chain strings. Okay. Next thing, interfaces with private methods. I don't know if anyone was aware. Java 8 introduced default methods, which gave the ability for interfaces to implement methods like an abstract. While everyone was trying out that stuff in Java 9, they have decided to add private methods within the interface itself to be able to communicate with that from within the interface. Let's try this out, shall we? Do we have enough time? Yeah, we have enough time. So, that's great. Food service. Yeah. So over here we're going to have a food service, and this food service will have public void make food. Yeah, that's fine. Make food, which takes string name, food type. That's right. String. Awesome. So we have, I believe it's something in relation to this default string message name. This is allowed to return. I made a sandwich for last name. And this is valid. This is as of Java 8. Also, of course, yes, you're right, I forgot to add. And doink. Yes? We can also do string get food bill food message. Okay. String name, return message space name. No. Unfortunately, just a sec. I have to go to this view. This is a problem with the version. Yes, no. Bear with me. Just bear with me a second. There we go. And it is happy. Okay, fantastic. Back to presentation. Okay. So, which means that any public implementation, food service input, implements food service, can now implement our methods of make food, yes, make food, or override food message. So what we can do this dot full message, pass it my name, and over here, okay, remove this away, no worries. Remove that in a second. My sandwich 4. So we can put this in a nice little message. Fantastic. Return this dot build message. Come on. No complaints. Okay. Interesting. So if we had to use this input as public, okay, void and string come on. And this is not out, but then this has to be there we go. But I think we have a problem with this group has to be static. So do the status doesn't become an override. We'll put this separately. Of course. Tell you what. Let's create a new class. Let's create a whole new class for this. Oh, fuck. Okay. Let's do another simple class. Hello. Yeah. Class. That's the main. Let's keep this simple. Okay, and we just do food service. New food service input. Does make food. Okay. Let's put this in its own class as well. Doesn't like it there. Okay. Let's just add a little message over here of our own. From okay, so simply running this.
I'll go back to presentation mode.
Yes. Actually, I'm not sure I can do because does it give it? No, it does not give it. It doesn't give me the console, so in theory. Back to view. Yeah. And the presentation. Okay, the service make food, and obviously you have to print. Make food. Make food is anyway, right? And this is make food into the voice. Let's do it from here then. Just in the house. Let's print that. Okay, time to make you laugh. So that's there. We now need to print this. We have a food service doing it. There we go. So, now let's do this again. And this. So, from private methods, I made a sandwich for Chris. Was that for just a little piece? But look at the power. From the impl, we overrode an interface method. The interface had its own implementation using a default. The default had use for the private method. Fantastic. Make sense, everyone? That is a debate at the moment because besides the multiple inheritance, why use abstract classes anymore if you can use interfaces like this? But
how many private methods and can you
as many as you want. As many as you want. I don't know. Cool. Exciting level? Okay.
This was mentioned in one of the previous talks, I believe it was Java 9 or Spring 5.1.
I think they've been up for it for a long time, but they've been looking for it for quite some time. Yes. Yes. I'm not sure on the visibility of default.
I would assume.
But the default is introduced in Java 8. Eh? The default is not part of this current implementation, so it's just easier to understand. Ah, okay. Possibly, yes.
What happens if you have multiple defaults? Multiple defaults is the same thing, so different interface.
You install the system two interfaces, which have the same default method.
Which brings the problem of multiple inheritance. Design.
Okay.
So, moving on, next thing Java 9 offers is modules. First, Java's first implementation or attempt at being aware of dependencies. It is meant to improve encapsulation, in fact implement strong encapsulation by limiting the visibility of classes to exactly what we want to expose and nothing more. It has a particular naming convention as well. It forces the JVM to be aware of the dependencies and stops issues of using global class paths and things like that. We now use a module class path, and the module class path is defined by Java in Java itself, which means that even if there are multiple instances of a particular class, we define the dependency version within the module, and our current module will use that. Like I said, module naming. So you create a class with the name. It's usually the inverse of the package name, starting from the back to the front. The implementation is this at the bottom, over there. I'm not going to try it out, but I'm just going to move on to something I think might be a bit more interesting. But also more features in Java are multi-release jars, which gives us the ability to specify a version of a particular class we want to expose to a particular JVM version. So it will decipher at runtime which class to use, depending on the Java version it's running on.
We can have two versions, and we say, for this one use this.
For Java 8 use this, for Java 9 use this, yes.
So we have two projects that
Exactly. You just compile and just tell it, use this version.
More angelic point was at least you were forced to use one version throughout the same project.
Like, for example, PSCPill client catered for both Java 8 and Java 6.
And one question is like about the dependency.
Yes. It's not dependency management per se. It expects these classes to be on the class path, but then it will pick and choose which bits and pieces to make available to you and what bits and pieces you should make available to others. So it's not like Maven. It won't import your jar for you from a million miles away, kind of.
This is at the class loader.
Inside of the class loader.
Like a little bit like OSGI works. So the class loader wouldn't be the usual Java loader. It's an enhanced Java loader.
Precisely.
Imagine, for example, you have an application and you have a list folder with a bunch of jars. Sometimes it does happen that you extract in the same folder, you end up with two different libraries, two different versions of the same library. It just picks one at random. This is how Java 8 works. This is Java 9. You would be able to tell it which version of those jars to pick up.
Which classes as well? Which different bits and pieces of classes and things like that. Like I said, not release jars and HTTP2. I won't go into depth too much in this. Hopefully I'll be able to show you some stuff. Okay, any questions about these? No? Fantastic. Moving on to Spring 5, and I promise you this is the last topic. Spring 5 implements Reactive. Reactive, and they're very, very proud of it. It's based on their project called Reactor Core, and they implement the publisher and subscriber patterns, and they implement the publisher in the shape of Flux and Mono. To me, they sound a bit like a comic book duo, and it's not the film either. They are publishers. Flux refers to a stream of many items within the result set, and Mono refers to a single one. They are similar to RxJava's observables. They are producers, and they are not data structures. They implement behavior defined to us by the Reactive Manifesto that I mentioned before, and they are used as such. They are not data structures. They do not contain data. Spring 5 made available to us Reactive Data and Reactive Web, which gives us the opportunity to interact reactively both between our endpoints and between our data sources. Let's try this out. More opportunity for much laughter and happiness. Sure, this is so. Spring 5 is offering the project's Reactive Data and Reactive Web as starters for us to be able to handle reactive streams. So like I mentioned before, all the behavior of Reactive and everything with it, using Flux and Mono as part of web MVCs and data access.
So the streams coming into the server, they would be the Flux or Mono, right?
Mm-hmm. And coming from the server. Mm-hmm.
And then with the Mono, what are we writing?
You can write a Flux, so a stream of data slowly happening, where we would be handling back pressure, writing slowly to the database as soon as the data becomes available. Data in the database becomes available, and we can read Flux. So as it's becoming available to the database, it's also becoming available to the readers, to the consumers of that data. Okay? We'll show everything. Okay, shall we try this out? I know we're a bit tight for time. I don't know if anyone has any other place to be. We've got a good 10 minutes left. Shall we go ahead? Is everyone okay with that? Yes? Okay, folks. So, let's go. Let's try this out. Hopefully, everything works out for us. So, first and foremost, I just want to show you something quite handy if you're going to try this out yourself. So, the project I am basing today's example is going to be downloaded from start.spring.io. This is a Spring initializer. It's provided with a ready-made Spring Boot for us. I'm going to give it version 2. That's for Spring 5. I'm going to give it our little peanut stuff for peanut.demo, and give it say a banking application which is event sourced. Let's focus on that. Reactive Web and Reactive MongoDB. Okay, so like I said before, it's providing us with certain dependencies that we can use for Reactive Web and reactive interaction with our data. And generate project from there. Okay, so that download, so I've gotten one prepared. Let's remove the stuff we've already done. Let's move this stuff. Delete. Okay. A banking application. Fantastic. So I will do this as fast as possible. Slow me down if you see me going too fast. Okay? So essentially what we're trying to implement over here is a banking application, which is event sourced. Let's make this a bit interesting. So event sourcing means that we're going to attempt to deduce the state of an object given it a series of changes. So let's say we're going to deduce, for example, an account from a series of transactions. So we would need the transactions, come through. So first things first, we're going to create a Mongo document for transaction. Transaction. Okay. We're gonna have a data. Wait, first things first. String ID. I'll give it ID notation. Shut up. Here. Private string account name. Can be handy. Private. Let's call it integer for now. Amount. What are we missing? Timestamp. Okay, fantastic. So we're going to get all the accessor methods, all the constructors. So we select none. Insert constructor, all these, fantastic. Okay. Accessor methods. Awesome. So here's our transaction. Super simple, super nice. So next thing we need to do is be able to store and access that from a storage point. So what we do next is create a repository. So we have a transaction repository that extends. This is going to be very specific. Reactive CRUD repository type transaction. That's a key string. Awesome. This is all done for us. Should be done anyway. Oh, of course, this is not that. This is an interface. Header. Now, next thing we want to do is start actually producing some events. So let's create a bean over here of command line runner. Let's do it this way. Okay. This requires us to return an arg. I think it's args, right? The method for that. Don't ask. Right, so essentially we want to produce a bunch of transactions. So first thing we want to do is produce a stream. So we have stream.generate new function, new transaction. And we want to create a new transaction. So we give it an ID, a UID generate dot random UID string. Okay. Next thing we want an account name. So we'll generate some account names at random. So here should be fine. Private generate account name. Let's give it some string accounts. Oop. Awesome. String. Okay, and some data there. So if we get the brackets correct. So let's say we have Chris account, Chris-001, and who wants their account in here with us? Clayton. Let's show 01. We're going to set your transactions. Fantastic. I promise you they'll all be positive. Anyone else wants their?
Pumpkin.
Pumpkin, of course. So we're in Pumpkin. There's show 01. That's good. Let's leave it at 3 for now. It's Chris, Clayton, and Pumpkin. The best party ever. Okay, so we've got what we want to return an account. So what do we want? Oh, of course, account has to have a return type, which is string. So what do we want? We want a new random. And the range, give me a random. Okay, accounts dot length. Okay, fantastic. So that will give us a random, and then we want to return an account and one from in there. Fantastic. New random dot next int. Dot oops, here we go. Dot next int. Here we go. And gives us a random one from there. Fantastic. So right now what we have is generate account name. Okay. And next thing we want is an amount. So let's do same new random dot next int. Let's just give it between 10. Awesome. And finally a date. New date. I think it's something like this. String integer date. String. Thank you. Let's double the brackets, let's double the font. There you go. Okay, so now I have a stream. So, but from the stream, we need to give it to the database. So what we want to do is flux.from stream, and give it already to the stream. Awesome. But this is just producing a producer. Without a consumer, we have nothing. So we have to subscribe. And what we're going to do is we're going to pass our transaction repository. And our transaction repository, of course. And our transaction repository will sort day save. I think we can do something like this. Is that it? Yes. Okay, actually, we should not do this because we want something out of this save. So, let's do save, transaction, there. Save our transaction, and also subscribe to this. So once this is saved, I want you to system.out.println and tell us, I have saved. And give us the ID. And let's say subscribe. T.get account name, get account ID. That save returns a flux. Flux? No, so it returns a mono, but still, it saves one. Let's still subscribe. Obviously, because it's a producer. That for t.get. So I think this should do it, or does it happen this way? No. I believe it should have something like this. No? Ah, of course. This is the new. Save transaction as .sp. Okay, so that's a stream of those. So let's make this a bit more interesting. So basically, we have a stream of data which is going to come in. We're going to be generating these at random. Essentially, what we want to do is generate these in an interval. So we're going to generate a flux interval. So interval equals flux dot interval for a duration of say every 2 seconds. Every 2 seconds, we're going to generate an event. So this is duration.
Every 2 seconds.
It's going to generate an event. So this is going to simulate back pressure. So we're going to have a stream which is going to generate immediately. One of the streams is going to be fine. The other one is going to generate an event every couple of minutes, every couple of seconds, okay? So what we want to do here is generate of seconds, if we actually get this right.
Telling subscriber is telling the producer to give me 1 every 2 seconds only, while
for this, yes. No, there's no subscriber yet. This is just an interval. We're just going to generate events on the bus, sort of. It's going to be stuff that we can work with. Essentially, then we need to combine these two. So flux.zip, we're going to use zip, which Natasha, one of the questions you were saying, this is one of the methods you can combine streams together. Okay, so one with back pressure, and we're handling this accordingly. We're by combining one from one to the other. So we're going to zip the interval, and what did we call this one? It has no name. So this is going to be a flux of transaction. Oh, no, not that. Of transaction, if we get some space, so this transaction flux equals that. Okay. Is there something missing? What did I do? Of course. Because this has to happen elsewhere. Sorry about that. This is returning a flux like this. Sorry, my bad. So we'll use that in a second over here. Okay, so here we're going to have a transaction flux, and I'll explain what I just did. So, dot map. Yes, exactly. So tuple. So what zip returns here is the type tuple. It will give me the return type. Will it give me? No, it won't give me. Here we go. This is going to return a type tuple if it shows somehow. No, nothing. It doesn't show. Anyway, let's return to type tuple. So essentially what we want to do is tuple2 to get t2, and we paste what we had before. So why can we do that? Can anyone say why we did that?
So that means that every 2 seconds we're going to generate the transaction. 2 seconds. So the transaction, the account is being generated constantly. But every 2 seconds we're going to take whatever was generated and save.
Essentially, sort of. So what we're going to do is it's going to generate. It's going to keep generating every single time it needs. Now forget the nitty-gritties of stream generate. Okay, here is assuming that we have whatever it is, it's data available on the bus immediately. So the stream is ready with data. That is executed once, but generates data per data per data per data, and you will see that in action. Okay. Actually, let me show this to you in action, so that at least we can already start getting an idea of what the hell is happening here. Now this can go away, and I believe we shouldn't have errors. And go. Oh, of course we have an error. 38. Oh, we're missing a bracket. Hang on. And run. I'll give this some time to start up. Oh shit. What's wrong? You're the index out of bounds.
Random, you didn't need to -1.
Yeah. That's next.
-1.
Counts.length.
Yes, -1. No?
Yes, you're 100% right. So sorry. Of course. New random. I think it gives a bound, no? No, next int was supposed to be there. My bad. Entirely my bad. Next int. There. That counts. Sorry guys, my bad. Let's check this one. So essentially what happened over there is we zipped the two streams together, so which is a way of reactively combining the streams together. And because one is slower than the other, we're assuming that one of the flux streams has data immediately. Malo, we're fine. Exactly. The other one is going to give us a result every couple of seconds. So it creates back pressure. One is going to have results ready on the bus, the other one is not. So one's going to produce one slower than the other. So with zip, we have imposed a reactive condition to say, when one becomes available, get the other one and bring them together and give them to me. As soon as they are available to me, they are available to you. Hence, we have a subscriber, which is then, this subscriber is then saving this to the database. Oh, sorry.
So how frequently are we actually calling the stream that generates the transaction?
Every single, so the stream that generates is just a method of creating a stream available to us immediately. Every single time one is available to zip from one stream, the generator is going to be called for this particular case, obviously. Now imagine I use this particular stream.generate over here as a way of using this as an example, but essentially it's just a method of saying, give me an event on this stream. Whenever I want one, there generate one for me. Okay? So stream.generate over there takes the place of where we would be iterating in general. Okay? Did I answer? Sort of? Maybe?
I'm not sure if it's actually generating as much as the processor is capable of right now, or...
No, it's not generating. Again, remember, this is... Because, again, just because for sake of example, assume that that stream is faster. Okay? Exactly. So assume that the stream is faster, essentially is just saying, give me a stream with ready data. Okay? I think it's getting a bit late. I don't know if I want to continue. Can do the web section. I don't know if anyone's interested.
We're talking about like actually share on your desktop, that's what it is.
Yeah.
I see.
But it's incredible.
Go lower state and more in detail.
Yeah.
Better illustration.
Yes, sure. We can do, I don't know if you want to do a very, very quick one though. We can do literally the website streaming data as it goes in Conda. Okay? Sure.
But we start thinking like, even I don't have to do it by event.
Okay.
We can't go over it.
Exactly.
But very good.
Nice. There, huh? Presentation, content.